Oh yeah, sure.
It's a little implant. I only have the one though. I couldn't afford two.
Well,
They don't sell them in a set.
Yeah.
you're way above my head.
Little implant. I only have
Having heard
Oh.
the joke like in plastic surgery.
What is in plastic surgery?
Every joke.
Okay. Got it. Okay, I guess we are starting. Dominic, Amanda decided she's too good for this podcast. Yeah, come do intro and then you can go.
Come in. Yes.
Hi guys, thanks for joining. This is Essence of Science. Today we're talking about infinity. I'm Amanda Armadas.
I'm Dr. Abbasi for Essence.
Dominic Moore.
Misha, Jimmy.
Come closer, guys. So,
Enjoy the pod.
Bye.
Hi.
so we are going to talk about the very abstract concept. Like when you grow up, Dominic, you learn first very straightforward thing that this is a pencil.
Mm.
This is a cat object. Then
Mm.
you learn more things like, verbs like, going
Gotcha.
or eating.
Mm.
Then you learn adjectives like, blue and so on. But still, you can point to some, there's nothing like blue, but there are blue things.
Yeah. Blue tie.
Yeah. So, but then we get higher and higher in our education and we understand then concepts. There is a nice the phrase attributed to Eleanor Roosevelt says that she said that trivial people talk about people, higher individuals talk about events,
Mhm.
but exceptional people talk about ideas. So I'm not sure if it's from her or she took it from somebody else and so on. But eventually, not everybody, but some people get in their life to a point they talk about concepts. And nothing really beats infinity. So we have few people here. Jimmy, tell me, what do you understand under infinity?
I think it's something really big. You can only get close to it. You can never reach it.
You
Something
can
like
never
that.
reach it.
Yeah.
Yeah. It is so it is infinity. It never stops.
Very
So-
big.
Very big, but I don't believe the word big really can be applied to infinity anymore.
Yeah.
Because big puts already a limit on something. So, Misha, what do you understand on the infinity?
I think infinity is not an observed concept, it's created. There's nothing tangible that we can call infinity.
We are not sure completely about that. We don't know if the universe is infinite or not. It might be that the universe and what we consider the concept of time might be, it's not a proof, but it might be infinite. But I give it to you, in our life, we never, ever observe anything that's infinite.
Or even remotely close.
Or even remotely close to it. Like, how many total atoms are in the observable universe? Universe is big, right?
Yeah.
It's mind-boggling big.
Mm.
But how many total atoms are in the observable universe?
I think that there's a finite number.
Well, in the observable universe, definitely is.
Mhm.
In the think that the universe, we are talking about billions of light years. We are talking about the stars that are like million times bigger than our star. But if you count all those atoms, it is less than a Google number. Google 10
Yeah.
power of 100
Mm.
is less than that. So there is less, photon in the whole universe than, and so on and so forth. So infinity beats all of that. So what do you understand on the infinity, Dominic?
I feel like my understanding is probably the more basis. I kind of see it as endless. It's the set between 2 points, really. We just say pretty much everything that is imaginable or could eventually be is within this set here.
Mhm.
And that's just kind of how we try to rationalize it. It's supposed to be a placeholder, but it doesn't really fit the way it should.
Yeah, it is a mathematical concept,
Hmm.
as Misha was saying, that we cannot wrap our head around.
Hmm.
Now, would that be a surprise to you guys that when somebody tried to come up with a mathematical concept of infinity, he was called crazy?
Uh,
I mean, people made a comment about the person that proposed zero as a concept. They
Yeah.
called that person crazy.
But that was few thousand years ago, or that was long time ago. That zero, what is zero? You know? But we are getting somewhere. I'm going to prove to you how crazy infinity is and how close infinity and zero are together. Infinity and now, well, let's imagine something with a triangle. A triangle.
Okay.
You make a wheel out of triangle. It has 3 edges, right?
Mm.
Now you make it quadrangular. That 4 angles. Now you make it more and more and more and more. You go to infinity. What do you have? A circle. Now, circle, does it have infinite angles or 0 angles?
Oh, okay.
See where I'm going?
Yeah, I see.
Yeah.
I see. All right.
So the concept of infinity, it is unbelievable that in the universe, at one extreme, you have a linear kind of progression. One extreme and the other extreme, somehow in the universe, they meet. That it's that cyclical thing that is going on, that infinite angle and 0 angle are become almost the same. Now, let's move on to the history of infinity. You know, in physics, often we come to physics applies mathematics to understand the universe. Often, when we are trying to understand that, like in quantum physics, in theoretical physics, and so on and so forth, in particle physics, we create a formula. When we work it out, we end up with infinity. And for a very long time, we had no idea how to deal with that. I mean, when you hit in a mathematical or theoretical concept, when you hit infinity, you're done. You cannot calculate it anymore.
Mhm.
And when somebody came with the idea of, do you guys know who came with the idea of infinity or how to calculate with infinity? George Cantor. Have you heard the name?
Yeah, I thought he was the guy who also like broke infinity, but and continue.
No, that was, well, there are multiple people. There was an Indian, actually, there's a movie about his life.
Mhm.
As well, the man who understood infinity, who took Cantor's work. Cantor was in 18 something. Now, everything that is moving in science is going to be denied at first. Do we know about that, right? What we do, people hate us for what we do because what we do is so far beyond them.
Mhm. Yeah, the choir
Okay.
here for sure.
Yeah. George Cantor was ridiculed, was ostracized. He died, not surprisingly, in the mental asylum.
Why do they keep doing that?
Why do you keep doing that? Everybody who creates something of meaning,
Mm.
who's far beyond their peers, is considered crazy and ostracized. And then, no, the one good thing about Cantor was that just toward the end of his life, he was recognized. Many people are not.
Right.
Okay, but so, and he came with the concept of infinity, you know, what that really means. How can you calculate? How can be that infinity is not the end of conversation or calculation and so on? How can you come with that? Now, let's go back to, you know, let's go back to what you understand. How can you identify infinity? I mean, how can you even wrap it around your head? Let's go around, Jimmy. Jimmy, what's the sign for infinity?
What is sign for infinity?
Yeah.
When it's too large that you cannot imagine?
No, but there's a sign, mathematical sign for
Oh,
it, right?
that's the 8. But
The
it's
8 on the side, right?
Yeah.
Yeah. Do you have any idea how we start using that as a sign for infinity?
I thought that was the snake that's eating its tail.
Oh, so
Isn't it?
Ouroboros or-
Yeah, that some people say it is that and so on, that, it's a snake that, is never ended eating its tail and so on. But more or less, it is practically the concept that there is no beginning and no end to it.
Hmm.
That is,
Okay.
More or
Like
less.
Morbius band.
yeah,
But
Mobius band,
The
yeah.
head is the tail.
Yeah,
It's
it's the end, it never ends. It's never, there's not an edge to it. There's not a beginning and the end to it and so on.
Hmm.
Yeah. Now, but now there are two kind of infinity. That is, I think to understand infinity. Now, so let's start with,
Okay.
numbers, right? Start regular numbers, 1, 2, 3, 4. You can start writing them down. You can just keep going. You don't have to stop. Is that right?
Yeah.
Yeah.
You don't have to stop.
Yeah.
Well, you may die,
Yeah, I was gonna say you
Round-
probably pass away.
but it doesn't stop. So you understand that the numbers, regular numbers,
Mhm.
as a set. So, and do you guys know what is the sign for a set? The parentheses and so on. That you parentheses, then the set, you close it.
Mhm.
So regular number is like 1, 2, 3 is a set, but as well 1, 2, 3 to infinity is a set of numbers.
Mhm.
Okay. Now, I think that was the idea that Cantor brought. To understand and be able to calculate infinity, you have to understand them as a set, not as
Mhm.
just regular numbers, because then it makes no sense. You can never end with that.
Yeah.
Okay. And once you understand that is a set, then you can start going somewhere. Again, a big concept that after Cantor brought it to existence, it took almost 30, 40 years for people to wrap their head around
Hmm.
that, yes, you cannot calculate with infinity, but if you understand it as a set, what are sets, Jimmy? Do you know what are sets?
Group of numbers.
Group of anything.
Yeah,
Hmm.
anything.
And and there are big concept. There's a big concept of sets in mathematics.
Hmm.
Okay, so can you give me some sets?
Like the R that stands for real number, I guess.
Yeah.
R,
Hmm.
Z.
Real number
Hmm.
is a
Q-
set. What else?
What's
What
the
else?
again?
Q is like imaginary, irrational, or something like that.
Yeah, there is a set of real numbers. There is a set
R
of
is an
imaginary
integer.
numbers. There is a set of all those numbers together. There is a set of sheeps in New Zealand. There's a
Hmm.
set of number of hairs in your curls in your head.
Hmm.
Everything zero is a set.
Mhm.
Empty. Empty
Empty
set.
set.
Yeah. Yeah.
Zero set and empty set surprisingly are not necessarily the same, because zero could be a set of a number that has zero in it, but empty set, it could be a set. As a matter of fact, one of the biggest work Bertrand Russell did was the theory of sets. And I'm not going to go there. There's a huge paradox, Russell's paradox about the set that, does a set of everything include itself or not?
Hmm. Yeah.
Okay, so
Yeah, it's
sets, well, it's still a paradox. So if it includes itself, how can it be in itself and so on? So it's a paradox. We go
Well,
there.
I need to pass discrete math.
Yeah.
That was one of the concepts I have to remember.
Okay, so
Every set includes itself and the empty sets.
and but that is a
Latest
big
definition.
concept.
Yeah.
See, we are getting to a mathematical concept now. Why the hell should we even talk about it? Okay, let's go around. Dominic, why do we have to talk about even this obscure, nonsensual? What kind of relevance does it have to anything for us to talk about it?
Honestly, I don't know. I don't know.
Nisha, what do you think? Why should we even care? Give it flying F word about this obscure concept? Why?
Because I think it really has to do with your view on mathematics, whether it is observed, like describing,
Mm-hmm.
descriptive, or creative. Like,
Yeah.
you think math is observed or created?
Mm,
What do you
You
think?
know, like, I think it's created. Like,
mm.
Then read a
I like
book
that.
called Mathematical Universe. Read that book. It's by Max Tegmark. It says that mathematics is discovered, is not created.
Yeah.
It's another obscure book you can read and so on. But Jimmy, why do you think why we should care?
You mean
Why should we care
we
about
here or as a human?
as a human? We care.
Oh,
Well, we four of us. No. Let's go another level. Why four of us should care about this kind of obscure? Why people who listen to us should give any care about this obscure concept of infinity?
I would say it's a curiosity. It's a human nature to be curious about things.
But curiosity killed the cat, right?
Yeah, but he did it
We're
8 more
not a-
times,
yeah,
you
we're
know?
not-
We're not cat, right?
No, but why should we care about it? Let me. What do you think?
So as a human species, I do kind of like the idea of we should understand the environment we inhabit, that sort of idea.
But we are not even sure if it's the environment, if it's just a brain fart. We are not sure about that. Why should we care about it? And I'm going to tell you why four of us should care about it.
all right, go ahead. Usually I care about it when I have existential crisis.
No. Well, let me. You remember the imaginary numbers, right? That like a square root of -1.
Yes.
Let's go a little farther back. I think it was 16th or 17th century, a French mathematician found the total brain fart at that time. His name was Fourier. Fourier. Have you guys heard of Fourier transformation?
Yes.
What is Fourier transformation?
I believe it's approximation of a function using
Sine
a
waves.
series of polynomials and sine waves.
Sine waves. So Fourier transformation, you get to obscure anything, you can describe it mathematically with sine waves. Why is it important? Imagine like you have some random signal, something that looks random to you. Almost like a language that you don't understand. Like you guys understand Chinese, but you and I, we don't understand Chinese. If you put a Chinese text in front of us, for us is like we can try to copy it, but we make so many mistakes that it becomes meaningless. But you guys, when you look at that Chinese text, you don't see it as a picture. You understand individual letters. You don't copy, you replicate those individual copy. You can write that text 10 times, 20 times, 100 times, and still not lose information in that.
You could even paraphrase it, like you would understand it.
And that's what Fourier transformation is. You take something that's not interpretable, you describe it in sine waves that you can replicate it every single time. You go through the same steps, you get that crazy pattern and replicate it. When it was brought to existence, it was crazier than infinity. It was crazier than anything else you can imagine. Lots of people there said, what the hell is that? I mean, why should we care about that? What if I told you now that CT machine just next room is uses Fourier transformation to create a picture of inside of your brain. So if you have a brain tumor, we can see it. All MRIs, all CAT scans, even X-rays that they use Fourier transformation to take the signal, amplify it, replicate it, to create truly a bigger picture of a small signal. So without that, without the Fourier transformation, We wouldn't know if you have a tumor in your brain or not. We couldn't save you. We don't know if your spine looked like. And that machine is just in the other room. So mathematics is 500, it's about 300 years before physics. Physics is about 300 years, I'm just exaggerating, before engineering. And engineering, what makes you able to talk in a microphone, have clothing, have glasses, get food. So is that good enough description why we should care about that, these concepts? Because now let's go to imaginary numbers, right? So for imaginary numbers, it's a huge, crazy concept that there's a square root of -1. It was brought to existence for us to be able to calculate things that they were uncalculable. And now without imaginary numbers, we would not have electronics, literally. Many of the calculation that we use for electronics is based on quantum behavior of certain elements. And if we don't calculate that, we wouldn't have GPS, we wouldn't have microelectronic and so on and so forth. And literally, you know, I'm going to divert a little.
Okay.
One of the most important reasons China wants Taiwan is because Taiwan Semiconductor Company, the company that the whole world is relying on their microchips and electronics. So it is a small island. You know, China could have, it's meaningless. China is so big and so on, and everything that Taiwan Semiconductor Company does is based on being able to calculate the quantum behavior of certain particle in combination so they can make microchips and so on. So we might be fighting a world war for imaginary numbers. Next step, infinity. Why should we care about it? Maybe not us directly, but you know, we talked about this concept. We don't know if universe is infinite or not. Okay, and it may not have direct impact on our lives now, but I can guarantee you, like many concepts that they were crazy for their time, I mean, mathematicians will find a way to deal with that, which they have. Physicists will find something in universe that applies that concept, and who knows, maybe someday Dominic, you become immortal because of that.
All right.
Now, let's talk about infinity itself. You know, there are two kinds of infinities. Some people count it countable and uncountable. I rather call it, infinity is not countable. That's just the name they give. I rather prefer the word sortable and not sortable. Like 1, 2, 3, 4, 5, 6, 7, you can sort it, right? But let's talk about, you know, like fractions, right? Well, so they say, for example, that there's more numbers between 0 and 1 than from 1 to infinity. How does that work? Do you understand what that means? So whole numbers, 1, 2, 3, 4, 5 to infinity. They say that's countable or sortable infinity. But let's say all the number between 0 and 1, like 0.1 or 0.0.1 or 0.0.0001 and so on and so forth, it never ends. You cannot really sort them. There is a lot more. Now, you remember we talked about the sets? The idea of infinity and is being a set. Then you have sortable or countable, or I call non-sortable, or what they call non-countable infinities. Is it if you can match them? And there's some crazy ideas here. I want to show it to you to understand, you know. and it's funny, actually, it's very interesting, entertaining, you know.
Mm.
Now imagine you have, before we go to a club, there's a set of 4 nerdy boys.
Mm.
Then there's a set of 4 nerdy girls. You can match us one to another.
Yeah.
But then imagine there's 6 of us and 4 of them. Now you cannot match them,
Hmm.
okay? Except if you have you. You take the 2 of them or something. Okay?
He's gonna get rid of the other 2 guys.
Yeah, or something. Okay, so
trim
we
it
have a
down.
set that we can match. Now imagine you have an infinite set.
Mhm.
You have an infinite countable set. You cannot match it with a set of infinite uncountable match.
So two.
Okay. But most of the calculation you can calculate, do mathematically countable sets. Like imagine, if we have a set of numbers 0, 1 to infinity, but then we have a set of even number 2, 4, 6 to infinity.
Mhm.
Are they equal or are they not equal? What do you think?
They're equal. You can, in theory, continue forever to match them up. 2 to 1, 4 to 2,
You just
6 to 3.
you got it. That is what the idea is. You can, like, some people may say, what about the even number, the infinite numbers, 0, 1, 2, 3, 4? They have all the uneven numbers that the other one doesn't have. So this must be bigger.
Hmm.
But in reality, as long as you can pair them, they're equal. Okay. Now, let's so let's have this concept of now that is where we come to the concept. Cantor invented that that you can how you can match them one to one. Let's do another calculation. What is infinity plus 1? How can you even add 1 to infinity?
It already contains 1 if you're going from a numerical set. So I mean,
It's still infinity.
No, it's still
plus
infinity,
1 equals
but can you do it? Can you add 1 to infinity? Or even better, can you add infinity to infinity? What do you have if you add infinity to infinity?
still infinity. It's the
But
same.
can you calculate that? Just imagine the crazy idea to come with the concept. How do we make that when you hit the wall with infinity, your knowledge, your concept, your brain, your intellect doesn't have to stop? That you can deal with that. You know where I'm going?
yeah.
That is the human ingenuity. Now, let's start. I'm going to talk to you now about Cantor's Infinite Hotel.
I do know this one. I do
Yeah.
know this one.
What do you know about that?
So this is the theory of you have a hotel, infinite number of rooms. But surprise, surprise, you have a bus that shows up with an infinite number of guests.
No, let's start with 1. Yes. So infinite number of the rooms. Go ahead. Every room is full. It's a very popular hotel. 1 guest shows up. What do you do? How do you add 1 to infinity?
Move them down, put them in.
You move the person from room 1 to room 2, 2 to 3, 3 to 4. So then you have an empty room, then you can put 1 in. So now infinite bus with infinite guest comes in. What do you do then, Michelle? In Cantor Hotel, Infinite Hotel, every room is full. Infinite bus with infinite guest comes in. How do you add them?
We should start with 1 bus with infinite.
Huh?
Yeah, you do the same thing with as if you're dealing with 1 bus. You just move the guest to the next room.
But that gives you only 1 room.
You move them 1 by 1.
No,
Remember
that doesn't work
something
that
like
way. That
Move
doesn't work.
everyone to the odd number room.
No, you double. You send them. You first send the room from room 1 to room 2, from room 2
To room 4.
4,
Mm.
from room 3 to
Three to
room
six.
6, and so on. Then you open up all the even
All the
number,
even,
all the
odd
odd numbers, and then you can put, because it's countable. Okay,
Mm.
that's the idea. If it's countable, you can calculate that. And so that this is just a concept
Mhm.
to make you able to calculate with the countable or sortable infinite numbers. Now, believe it or not, one of the absolute biggest breakthrough in physics, again, all the macroelectronic use
Hmm.
quantum physics to calculate. One of the biggest breakthrough in quantum physics is a process called the renormalization. What is the process of renormalization? Obviously, you know, just break it in words. Just when I say a renormalization,
Hmm.
what do you understand if I say that?
Return to normal.
Return to normal. So something is not normal, you return to normal. In physics, what, especially in theoretical physics, what could that be?
So I know what a normalization is. In mathematics, normalization is kind of like you project a series of number into a normal range. Like suppose you have a distribution and then you can normalize the distribution by their relative distance from the middle.
Statistically, yeah.
Statistically,
No,
from 0
but
to 1.
this is in physics is a little different, okay? In physics, the concept of renormalization is that like many times when people try to come up with a quantum physics or theoretical physics concept of the matter, and you know, in quantum physics, you know, the idea is that everything is a wave.
Hmm.
They collapse when you look at them.
Hmm.
And then when you're trying to practically come up with the idea how something would behave, like an electron. And this is not brain fart. This is how your cell phone works. Okay? How literally the GPS and all these electronic things work. The behavior of electron is what the electromagnetic and the computing and so on, that's all what plays now. So this is not brain fart. But when you come with the concept of how they work, how when you look at the electron, is a wave, is the wave that can pass through the matter, or is it the particle that will stop there and you give it a little more germanium to the transistor, for some reason it stops, or you give a little more of something else, it passes through. So this is not brain fart. But when you try to calculate the behavior, and that's what a processor is, that you predict the behavior of the electron, that the information gets calculated this way or that way. When you try to do that, you hit a wall because you hit infinity. In the calculation, all of a sudden, infinity appears. Because you're trying to go from one place to another, when you get the limit of it, all of a sudden you have infinity. The renormalization is the process of getting rid of infinities. And the way you do that, you take one infinity and another infinity that are countable, and you subtract them from each other. And what you are ending up with a mathematical formula that is not nonsense, and it tells you the behavior of the electron. So I just gave you why we should give a shit about infinity. Okay? So, and that is actually, you know, that is something that has made us understand. That was one of the biggest contribution of Richard Feynman to quantum electrodynamics, the process of renormalization. I'm sure you guys have heard of Feynman diagram and so on. He made a very difficult concept understandable by Feynman diagram, one, and second by process of what we call renormalization. So, because we could go on, but you know, I hope I could show you why we should care about an abstract, something as an abstract concept as, you know, infinity. And as well, I hope that people understand that almost every person who has mattered in our human history has been called crazy.
Yeah.
You know, it's actually kind of interesting that we bring it up too, because every time I think of a physicist or anything like that, I always think of them looking at infinity and just hating it, because they live in a world of statistical probabilities, you know? Is the atom over here? Okay, 2% of the time. Is it over here? Like 90% of the time. So the idea for them to look at infinity and go, how the hell do I get rid of this thing? That just makes sense to me.
No, they hate it. That's why they do the renormalization, to get rid of it.
Yeah.
But not surprisingly, once you understand the concept,
Mhm.
you create a mathematical kind of solution for that. And then you come, and that's all what's about. Physics about, like, why should we care about physics, right? Well, you go as a cat, you go, you look down the building. Am I going to make it or am I going to die? The cat is doing physics in
Mhm.
her head. Okay, the biology, like you see a lion is coming to you, or fox is chasing the rabbit.
Mhm.
Okay, how does the rabbit beats the fox? Because fox is faster than rabbit. How does the rabbit beat the fox when it's being chased?
With frequent turns.
Mhm. Yes, because it could pivot faster.
How does the rabbit knows in what interval change the direction? And how does the fox sometimes can match it, sometimes it cannot match it? So if fox is better at calculating the pattern, fox will live and have more children. If the rabbit can calculate that in his processor, how random it should be, those things, those change of direction, rabbit will live and have more children. But make no mistake, physics is running
Mhm.
in both heads to make one or another survive.
Mhm.
I throw you a ball. So I throw you a ball, a baseball. You're doing physics.
Yeah, how fast is this thing coming, you know?
Can you hit it or not? If you hit it, you get a contract for $200 million. If you're not good at it,
Mhm.
nobody will give it
Yeah.
any care.
Mm.
So you are running physics in your brain, and that can be $200 million
Calculate.
contract
Yeah.
contract for you if you do a good physics
Yeah,
or
do the
bad
equation,
physics.
do the equation, let's go. What's the velocity?
There's always
No, your body does it actually, your
Mm.
brain does it.
Intuition.
But we call intuition is just a complex mathematics.
Mhm.
That's what intuition
Like
is.
a sense of the answer.
Well, now there are some very weird people who can add and subtract and multiply unbelievable numbers or remember unbelievable things. Like you guys have heard about the Rain Man guy who
Yeah.
could just read a telephone book and memorize everything
Oh, I
in the
didn't.
Yeah.
telephone book.
Oh, yes, yes, yes.
Yeah.
I was like, then
So those people who do that, they have a ability that in their brain they visualize those numbers. Like there was this guy who could get the square root of unbelievably big numbers. He would go in his brain, and then he would have this form that it would loses. He would describe it. He would that it was a complex form, and then little by little that complex form would lose edges until the edges were there. He would just go and count them and give you the
Hmm.
square foot. See, his brain, the biological thing, has come up with ideas to run complex math.
Hmm.
And we don't have, well, take a calculator. Do you understand how the calculator works? No, you still can use it, right?
yeah.
We don't have to understand how our brain works
Hmm.
to be able to use it.
You know, there was one mathematician, this was many, many years ago that I remember seeing his, like him doing something. And he had such a hard time explaining because essentially him working out formulas now is he will just say a number, just speak it out into the air as he's doing it to put it in a different location in his brain.
name is Ramanujan.
Yes, yeah. And he draws kind of just like strange abstract shapes on the paper, and that's how he looks at stuff too.
Yeah.
extremely ugly formula, but extremely elegant.
Yes, yes.
No, there is a book, there's a movie called The Man Who Knew Infinity. It's about the Ramanujan,
Mm.
the Indian mathematician who did more work on infinity and so on. If you're interested, very nice movie, very soulful movie. By the way, he went to Oxford based on he came from a very humble background. He went to England in I think Cambridge or Oxford, And then it was a time of the Second World War. And he was, I mean, it's not unnecessary to say, British society was and still is extremely,
Yeah,
Racist.
yes, very.
okay? So if you are not from there, they would diminish him, they would even beat him up in the campus and so on and so forth. And his life is very interesting, okay? So I really recommend for this weekend, for people to go and watch that. The Man Who Understood or Knew Infinity, one of these. I forgot if it's understood or
Easy enough to find out.
yeah. Well, I think we should wrap it up while it's still interesting. Okay. Any final words? Any comment?
Oh,
No?
yeah.
Okay,
good.
well, thank you for Essence. This is Dr. Abbasi.
Dominic Moore.
Nisha?
Jimmy?
Okay, thank you for joining us.
Bye.